Good morning, everyone. I see everybody joining in. Today, we're here to talk about machine learning platform for anti-money laundering from Hopsworks and our partner Infrix. We have Yogesh on, who's the CEO of Infrix, who spent a number of years at Citi as the chief solutions architect for anti-money laundering. Welcome, everybody. Today's agenda, we're going to talk about the business problem of ML-driven anti-money laundering, why Hops works for anti-money laundering, and then we're going to go through a demo on AML using HopsWorks as well as the no-code Infrix solution for developing an AML system with machine learning as well. And then we'll go through a short Q&A. Again, thank you everybody for joining. In a world where machine learning is increasingly driving profits, companies are turning to the Hopsworks platform to build better ML-driven applications and deploy them faster and cheaper. Below are 4 areas where Hopsworks can help any enterprise to gain value with ML-driven applications. Hopsworks platform can help you develop better predictions. Features are trained at consistent points in time. Models are served by fresher data and features at any scale. The second way is through team productivity. The Hopsworks platform is able to free up your data scientists to focus on high impact tasks, maximizing contributions to your organization. The third way that we drive value is by having more models in production for our enterprises. We help accelerate your organization's ML adoption by rapidly deploying and managing more models in production. And the fourth and final way is to release ML to market faster. The Hopsworks platform drives and accelerates your machine learning initiatives, enabling rapid model deployment and quicker time to market to help you get models deployed at a faster pace. In total, I think the quote at the bottom demonstrates this the best. This is one of our customers who said, we experienced a 3 to 4 productivity increase or gain while vastly simplifying our machine learning code base and pipelines. We achieved ROI within 6 months of deployment. This speaks volumes to the Hopsworks platform and our ability to drive ML-driven applications at a faster and cheaper rate. Today, we're going to be going through anti-money laundering. You can see at the top here that there are various ML-driven applications that are on the Hopsworks and Infrix platform. There are other webinars that we're hosting. We just hosted Next Best Action yesterday. It should be on our YouTube channel today. If you'd like a copy too of the slide decks that we're presenting, please reach out to me at nathan.greenhut@hopsworks.ai. We're also going to be going through personalized recommendations, generative AI, LLMs, credit risk, customer 360, identity and access management, and our identity resolution solutions. All of this is built on the Hopsworks platform. We have a feature store, open search, vector database, model registry. We're integrated with Kserve as well as 30 other stitched together components that make it easier for you to adopt and use ML in all of your applications at a much more rapid pace. I'm going to hand off the session to Yogesh, who's going to show you the Hopsworks platform as well as our integration with Infrix. Yogesh.
Yeah. Hey, Nate. Thank you. Perfect. Yeah. Hi, everyone. I'm Yogesh. I'm the founder and CEO of Infrix. We are a partner of Hopsworks and Neo4j. We are a low-code application accelerator. We have a platform which allows you to build your AI applications without writing any line of code or minimal coding. You can build the application, you can deploy, you can monitor You can do feature engineering around your AI ML applications. And we also have Graph Engine as a part of the platform, which is Neo4j, which allows you to do like a graph analytics, graph algorithms, do graph engineering, and then bring those features together with the other features on the HopsWorks platform. So there are various use cases the platform supports. It's a horizontal platform. It allows you to do, like there are some of the examples here: customer risk and fraud analytics. Today, we are going to talk about the anti-money laundering, which falls under the fraud analytics. I personally worked in this space for more than 10 years at a big bank, and I'll be sharing my experience and also showing you how quickly you can build these applications in a no-code fashion with Inferix and HopsWorks as a platform together. So I think the agenda is like, first we need to understand that why we need to use the machine learning for this kind of application. What are the different approaches? How can it, impact your cost and time to deliver? And what is the value addition, we bring to the table for the business while using machine learning? And then once you make a decision that, okay, you want to use machine learning, then there are options, right? You always have a build versus buy option. There are pros and cons on build versus buy option. So we're going to talk about it. And then we have, like, obviously HopsWorks, like how is a HopsWorks going to help you basically implement this application in a faster time space, and how can you save cost and also have a very maintainable application from the long run perspective. So why machine learning? So as you all know, the traditional AML systems have been built using rule engines, right? And not only AML, but many other applications are at the banks are mostly, like I would say 95% of them are running on rules engine. And rules engine have a lot of advantages. I mean, few advantages, but a lot of disadvantages in today's world. The biggest disadvantage you have is, like, the rules are pretty static in nature. They don't really change on a weekly or a monthly basis. They kind of remain stagnant for years and years. The only thing really changes is the threshold, but there is a constant threshold tuning that you have to keep doing and catch up with the fraudsters. So this becomes a very manual exercise. It involves a lot of infrastructure and money and human time, and that's not really the best way to manage an application or catch fraud. So that is where machine learning comes into play. As you know, most of the banks are using machine, like they're either experimenting or they are into a pilot phase when it comes to applying machine learning to AML application. We are going to show you a live application today, how you can get started using HopsWorks and Inferix, and what are the benefits of it. So some of the challenges, that the machine learning problem can solve for you. So generally, these are the three major challenges. So one is ingesting the quality data, right? If you have garbage in, it's a garbage out. So the rules engine are not going to come back and say that, there is something wrong with the data, because the rules are pretty static. They run on a certain business logic. They have some thresholds, and they will give you a result saying whether there is a fraud or not a fraud. But because of this approach, 95% of the alerts that are generated in today's world are all false positive, right? Everybody knows about this. And the only way to solve this problem is to not add more human resources or human time to it. The best way to solve is to use machine learning, which can automatically train itself on a periodic basis or on a required basis. And then, it can basically detect these things, right? So machine learning can not only be used for generating alerts for fraudulent activity, but it can also be used way ahead in the process, which is like during ingestion of data. So you can load all the data, you can run the ML models, do data anomaly detection, which will tell you what are the what are the bad values, what are the out of the range values, and so on. So you can use machine learning for your data quality aspect as well. Then comes deploying the accuracy of the models, right? So once you build the model, then you need a system which can allow you to seamlessly deploy this model, do your complete automation on the CI/CD process. This is where HopsWorks comes into play, where it allows you to use like one single platform where you can not only build your models, but also do the deployment end to end from development to production on a point of click, right? You don't have to really do a lot of coding, or you don't have to involve a lot of human time, and make sure that you have the 6 nines of availability, and also it eliminates all your data leakage. So there is a very classic problem in machine learning world of the data leakage, which HopsWorks internally takes care for it. SLA is again another thing. Like if you're building something from ground up, you need to make sure you have the right experience to build these kind of systems, and it's not an easy thing. So normally banks would go and buy some third-party product. Yeah, definitely you can solve by buying a product, but you're only solving one problem, which is AML. Now, if you have 10 problems in hand, you cannot buy like 10 solutions, right? Or 10 products. It becomes too expensive and it's too much to integrate and maintain. So rather, an option would be that you buy something which is more like a framework or a platform which allows you to configure your applications, and you can run multiple applications on the same platform. That way you can not only solve like, one problem, which is AML, but across the board, you can solve multiple problems in the risk and the compliance and the other departments. One other advantages of using a platform like HopsWorks is that you can bring all your features in one place, because at the end of the day, HopsWorks is an ML platform which contains a feature store. The feature stores allow you to maintain your library of features. Now, the same features can be used consistently across multiple applications. So that way you have consistency of the usage of features, and that makes sure that, we are not duplicating the effort of building features in different departments, and at the same time you are getting accuracy in terms of your predictions as well, right? So HopsWorks as a platform will make sure that you get accuracy in your models, you're able to deploy faster your models, and then also maintain the performance, because that's a big aspect. I mean, you can certainly write a lot of code, you can do all the open source development to build your models, but if you cannot keep up with the performance, then you're still not solving the problem. So HopsWorks as a platform will make sure that you get the best performance and you're able to do both real time and batch. So it has features which are very specific to real time and batch operations. And depending upon the use case, you can choose one of them to use it. Okay. Now, why an ML first approach, right? So there are two options. Either you can take your existing rule-based systems and you can start patching those systems and try to somehow sneak in machine learning. So one option is to you can generate the alerts out of the rule engine, and then maybe you can prioritize those alerts through an ML model. But again, your upstream limitations are still there, right? You still can only process a small volumes of data because you're applying ML after the rule engine, and that's not going to really solve the core of the problem. Plus, the way the rule engines are built, it's a very waterfall development approach, right? You take a rule, you develop it, and it goes through the whole SDLC cycle, which can involve multiple teams, and it can impact multiple components. Typically, as per our experience, we have seen there are more than 20-25 components which are involved in an AML system. And then it can obviously take years and a lot of money too, right? It can take multiple years and large amount of money because it's labor intensive. The challenge is it's labor intensive. So the only way to eliminate this labor-intensive process or the bottleneck is to use machine learning right from day one. So this allows you to scan the full set of data. You don't have to work really on a sample. So that way you are able to, achieve like a better coverage in terms of what patterns are there in the data. You get a better result in terms of the prediction. But again, if you're going to scan all of the data, you need to make sure you have a platform which can support that kind of scale. And that is where Infinix and HopsWorks comes together to help you on the problem. Again, you're building all these applications, ground up using machine learning approach. You can be more agile because typically if you would do a rule engine approach, you develop a rule, you test the rule, you have to go through the whole SDLC cycle, which takes a long time. But with machine learning, you can do the continuous learning in the production environment itself. Because if you want to do like a threshold tuning, you have to go back to your dev environment and start the whole SDLC again. When it comes to machine learning, you can run a champion challenger model out of the box on the platform, and then you can keep a track and see if the challenger model is doing a better job than champion, and then you can switch it. So there is a continuous learning aspect involved when it comes to machine learning using HopsWorks as a platform, and it makes you more agile, you save time, you save money, and that is what the goal is, right? So now once you make a decision that you want to use machine learning for AML problem, then you need to make a decision like how you're going to do it, right? Is it going to be a build option, which requires a lot of experience and take like dozens of open source project to build on your own? Or you can buy a platform which is using open source to begin with, because using open source means you are having an open architecture. You can integrate very easily within your existing ecosystem. And at the same time, you're getting the power of the community, right, of an open source technology. And that's where HopsWorks and Inferix comes together, which is more like it's really a hybrid between build and buy, where you can buy the platform and then you can start building applications on the top of it. But you're not building from ground zero. You're kind of building really from focusing on application rather than focusing too much on technology. So, you know, so it depends on the requirement. So like, typical ML application involves a lot of components. You have to do like a lot of data engineering before you actually start solving the AML problem. Once you do the data engineering, bring the data in, make sure the quality of the data is good, then you have to kind of, apply the rules, generate the alerts. Again, there are limitations in terms of the rule engine. That is where the ML comes in, right? And then if you want to build, then you want to make sure that you have enough experience on the table in terms of data engineering and data analytics, which is the data scientist world, to build these kind of systems. Certainly, you can, write few lines of Python code. You can make it work on your laptops or, desktops. But when it comes to operationalizing such models, it could be a big challenge. And that is where HopsWorks comes in, because HopsWorks is an integrated solution where you can build, configure all these components and build your AML application, without getting too much into the nitty-gritty of the technology itself. It allows you to use the Python APIs, which will allow you to do feature engineering. You can build your models, and then you can save and run your models on the platform. Or you can also use Inferix, which is more like an accelerator sitting on the top of HopsWorks to manage your application. So you have both the choices. You can do an approach where you are coding using the raw Python APIs that comes out of the box on HopsWorks, and also you can use the Inferix platform to manage your application. So accuracy, like testing the models, like training the models, making sure the accuracy is good, making sure the scalability is good, making sure you are able to do an end-to-end automation of the CI/CD process. These are all the enterprise features that you get when you get the enterprise edition of HopsWorks. And obviously, we are maintaining the platform for you so that you can focus on the application, right? Instead of managing both. And I think that is where people lose really the sense of solving the business problem, and they get too techy about building a platform. And I think if we can join together where we supply the platform and you build the application, that would be a best option, right? Because now you can build more application in the same amount of time and with your existing budget. This is one of the snapshot taken from our recent experience from the past, where we have seen, like, how complex of an architecture it can be if you're trying to build your own AML system. It involves a lot of data engineers, data scientists, you need testers, and then you need to make sure that you are keeping up with the technology upgrades, right, at the same time. And that's where things get complex. It could be a lot of components that you need to build and keep switching depending upon as technology changes. But HopsWorks is here to simplify your architecture, right? I mean, you just need few data engineers and data scientists to develop this pipeline. So at the core of it, we see at a high level, there are three major pipelines: feature pipeline, training, and inference. Feature pipeline is where you're building your features and making it available for multiple training ideas across multiple use cases. And then just through an API, the data scientists can consume these features, they can train their models, and then start making predictions on it. So there is an inference pipeline which allows you to do both real-time and batch predictions depending upon the use case. So the whole problem we are boiling down into three major components: feature, pipeline, training, and inference. And we have APIs, we have Inferix as a platform which will allow you to build these pipelines, either using APIs or with coding, whichever approach you like. And then you can get rid of, all these multiple components that you have in place today, right? Um, that's how it can simplify your overall architecture. I believe so. This is one of the high level view of the HopsWorks and the Inferix platform together. As you can see, like, you have we kind of take care of the whole technology stack here on the HopsWorks, where you can now start building your application, right? And then you have application layer on the top of it, where you can build various applications like generative AI, personalized recommendation, fraud detection, and so on. So as you can see, this platform can really help you build applications across domains, across various departments, and it is very agnostic of use case as well as the industry, right? So no matter which industry you belong to, you can still use HopsWorks and Inferix as a combination to build your application. We have the low-code accelerator as well, which is the Inferix component, which allows you to build these apps. We are also Python first, where you can use these Python APIs, where you can build your apps using the Python API as well. So if you have existing models, existing code, then you can integrate through the Python APIs. But if you're building something from scratch, then you have the opportunity to use the low-code accelerator to build your apps, right? So both the options are available. So now we just understood, like, why we need a machine learning to solve the AML problem. We also saw the high level view of the two platforms. Now we can talk about the business process, right? What are the challenges within an AML world? I mean, as I mentioned, The major challenge is really the rules, right? These are very static in nature. They don't scale well. They scan a very small amount of data. They're very black box type of approach, right? Where you don't know like what's happening in terms of if you're buying a product, then obviously you're getting something out of the box. But then if you're building your own, then the complexity evolves, right? And these rules are static. You have to periodically tune them. They're very meant for like a batch-oriented system. They're not really for real time because with a machine learning model, you can kind of answer the questions very quickly. And especially with the introduction of Gen AI, now we can also bring the unstructured data and answer the questions, which to help your fraud detection problem, right? The AML problem. So HopsWorks plus Inferix is going to allow you to give you that open architecture where you can interact with the platform. You can build your applications in a no-code fashion, and then it becomes more like a white box rather than a black box solution. So this is the rule-based approach. You have your source system, you bring the data into a data warehouse, you go through a bunch of processes which are managed by humans. You run through the rule engine, you generate the alerts and so on. But again, the system exists today, it satisfies the regulators, but as you know, the problem is still not solved. Majority of your alerts are all false positive, and you end up spending not only problem in terms of spending time in building your system, but then there are investigators who are wasting their time in looking into those non-productive alerts. So nobody is really gaining anything out of this except the fraudster. But in case of the machine learning, we are continuously learning. So you can still have your rule engine in place. You don't have to like rip apart. But what we can do is we can bring the platform and you can enhance your existing alerts using the machine learning approach. And then you can also start building the models, which acts more like a challenger model to your rules engine, and so on. And slowly you can go towards your journey of machine learning, right? So now we can get into a quick demo. So before the demo, maybe Nate, if there are any questions, I can take those. Uh,
Yogesh, there was just a question about how we could get started and get even more technical. I think you're about to show some more of the details, if you will, on our platform. I let the Dave know that we also are more than happy to start a POC with him on a specific use case, and that he could reach out directly to me. Do you have any other points they would want to make on that as well?
on the POC, you mean, or I mean, what is the
In
question?
terms of getting into the technical details, I've also mentioned like that there's a GitHub repository where all of our code is for open source with HopsWorks, and that we would get into some more technical or show some more of the technical details in the demo as well.
Yeah, sure.
Um,
I mean, obviously we'll go through it. You can ask any specific questions if you have on the tech side of it, or otherwise you can go through our website and then go to the webinars, the past webinars. There are webinars which are specifically on the technology side, both on the Inforex as well as the HopsWorks platform. And then obviously you still have questions, then we are happy to, have a follow-up call and then we can deep dive into the architecture. So one unique thing I want to mention or highlight here is like HopsWorks and Inforex are available both on-prem and cloud. This is very, not every application or a software is available in this fashion. Either they are 100% cloud or on-prem, but we are compatible on both sides. So you can even do an hybrid if you like, but we can run either ways. And that really gives you a lot of flexibility if you have an existing system in place on an on-prem and you may not want to share your data on the cloud. But if you want to try it as on the cloud, we can do end-to-end solutioning on the cloud as well. Okay. So you can literally install both the softwares within your private cloud or maybe on-prem. Okay. Okay, so let me now get into the demo. So what I'm going to do is I'm first going to go through the accelerator, where I can show you how you can build your features, your AML application. And then I will show a few things about in terms of the HopsWorks under the hood, how it is being leveraged, how the features are getting stored and the models are getting stored. So in this particular demo or in this application, we are using three different products. We have Inferix, which is a low-code accelerator. Then you have the HopsWorks, which is the ML engine and the feature store. And then you have the graph database, which is Neo4j, because we are also extracting the power of the graph engine. And we are bringing all this together in terms of the feature engineering and then storing those features in HopsWorks. So at the end of the day, all the features are getting into HopsWorks. Inferix is your mechanism to build and kind of save those features. And Neo4j is kind of giving the power of graph to add value to those features stored. So once you log in, you have access to various applications. As I mentioned before, this accelerator allows you to build multiple apps. Today, we are going to focus on the anti-money laundering. But as you can see, we have claim fraud, credit card fraud, customer analytics, and so on. We have multiple webinars that are coming up. You can check out the page and you can register for that as well. We will also go through these apps. And even in the past, we have done it. So you can look at our recording as well. So getting into the AML application. So these are all the modules that are available in the Inforex accelerator, and you have basically like a data management pack, which allows you to take care of your data, like pulling the data from your source, massage the data, do some data preparation, do the data quality check, and so on. So either you, and you can then also do migration. Let's say if you're an existing platform like an AML solution and you may want to hop onto our solution, then you can also do a migration of the data, which is like a one-time historical migration. Then you have the business rule engine, the alert generation, where you can define the business rules. Now, these rules can be the traditional rules, or you can define rules as on the outcome of the predictive models, because you may still use a machine learning approach, do the predictions, and then combine the prediction output along with some business knowledge to generate an alert. And then once the alert is generated, we can take it through the case management journey where the investigator can start investigating these alerts, right? At various places, we use like, HopsWorks as well as Neo4j in terms of the graph technology. Then you have entity resolution, which allows you to basically resolve your entities, make sure deduplicate your customers. That is really the first step, right? You want to make sure you are deduplicating your customer before you start analyzing your customer. Otherwise, you may be investigating the same customer twice and you may not get the full output of your analytics, right? And then we have the data science where we can start the feature engineering, we can store the models, etc. And then we have pipeline, which allows you to automate like end to end from left to right. So let's start from the rules, how the rules are configured here. So there are various rules here. You have the outgoing wire amount transfer. So I can look into one of these rules. These rules, you can point to the data where your data resides. So I'm looking at account summary daily. You can apply some filters. You can parameterize these rules. And then I can start defining the criteria. So this is the classic way of solving the AML problem, right? Now, what I can do is in this rule engine, I can also add the outcome of the predictive model and make one of the criteria that if the predictive model says that, there is a 70% chance of an AML fraud in this particular transaction, then we would like to get an alert and get and block the transaction. So that's how you can use the power of the rule engine. Okay, so you may still need a rule engine, but not to do the whole, the old-fashioned way of defining your AML rules, but you will actually use the power of rule engine along with the machine learning approach, right? Then you can, once you define the rules, then you can start defining your alert generation rules. So in the alert generation, you can say, I want to look at all the suspicious customers. You can pick the rule on which you want to generate the alerts. You can combine the rules as well if you have multiple rules. Each of this rule can be sitting on the top of an ML model. You can have multiple ML models, each using some kind of rule engine to score further. So it's really going to allow you to aggregate your score out of multiple models, right? So if you have three ML models making a similar prediction, then you can take those three scores and you can combine into a single score using the rule engine. Once you combine the score, then you can apply some kind of threshold on it. In this particular case, I'm saying if the combined score is greater than 70% or a 70, then please make an alert, And then depending upon the value, we are going to bucketize them into a low, medium, high priority of alert. And then you can get alert notification, you can get the job notifications and so on. Then the next step is to take these alerts and start creating cases around it. So I've already configured the case rule here, which allows you to further combine these alerts. So you can be into a scenario where you have multiple alerts coming out for the same customer because they may be having different product lines. They may have a credit card product as well as the debit card product, and you may have different alerts on it. But you may want to investigate that customer only once rather than multiple times. So what you can do is when you define your case rule, you can combine those multiple alerts into a single alert and you can generate more holistic score. So if you see all the way from the business rule to alert to case management, it is an aggregation of scores, right? And then you can have a top level score, which is 100 in this case. So this is a high priority alert. So I can say I want to investigate this case. I can see all the case information. I can see which customer it belongs to, what is the priority. I can switch the priority if I like here, when was the case generated, and so on. Then I can look at all the details of the underlying customer. All of this is configurable through configuration. I was able to define the rules, define the alerts, and generate the cases. And once you generate the case, whatever fields you would like to see on this particular screen, you can configure that as well. So we are looking at customer as an entity. These are all the fields that are available in the database. Um, we can look at all the alerts that contribute to the particular case. I can drill down into the alert. Now I'm looking at an alert which is running on an account. So a customer can have three accounts, and I can have three different alerts on three different accounts. So I'm looking at an account at this point, and what are the account details? What is the balances? When was the account open? Any kind of ID, etc. Then I can see what rules were, contributing to generate these alerts. So as I was mentioning, each of this rule can be using an underlying ML model. So I'm looking at an alert, at a rule, and then what rules were fired, what were the criterias, and then I can drill down further to a transaction level. I can also see what else is connected to this account. So here I bring you can bring the knowledge graph if you like. You can see how the money is moving into the flow of funds. So let me switch back to the case management. So we were at the alert. Now I'll go into the link analysis. Let me switch to another environment here. Okay. Okay. Then go back to the anti-money laundering. So I was on the case management. I go to the analysis. I open the same case again. I go to the link analysis. Okay, so here you can see like for that particular customer, what are the connections? So we are looking at a customer, which is this particular customer. If I want to see the details, I can click on this and I can say, show me the details. So you can get all the details out of it. This data is right now coming from your underlying database, which is Neo4j in this particular case. Then I can look at what account the customer belongs and then which branch he, and also there's a flag called PEP flag, which is telling you that this guy is a politically exposed person, right? So this may be something that you want to keep on your radar. Now I can say, show me everything that's happening under this account. So I can double click this account and I can see what other transactions are taking place between the accounts, right? So you can start navigating this graph using the case management dashboard. This is where Inferix brings you the power to the in the hands of the investigation agent. I can also look at how the money is flowing between the accounts. So these are all the account, and there are four accounts which is moving money into this account. And then we are consolidating all the money, and then it's kind of further dividing the money into multiple accounts. So this kind of shows you how the money is moving between the accounts or hopping between the accounts. You can add some notes, you can attach some documentation to this particular case while you're investigating. One other powerful feature I would like to highlight is the workflow engine. So the workflow engine, basically, you can configure any workflow. We have a workflow manager out of the box, which allows you to configure your workflow as per your business process. This is a workflow which we have created for one of our customer, where it says initiate the case. When the case is generated, we get the case details. We see to which analyst group we want to assign. You can apply some kind of business rule saying you want to assign this case to an investigation group which belongs into the same region or the same location or maybe the same branch. So all these rules can be applied. So you can do routing of cases when you're assigning these cases. Once the case is assigned, then we can inform the investigator that a case has been assigned to you. It'll go to the level one, then you can start investigating. We can send reminders as well in terms of the notification in case the investigator is not taking any action on it. So here it's a very complex process where it is kind of like going to level one, level two. From level two, then it can even bounce back to the level one if needed. So you can send it for re-review. Then again, we can assign the case to level one and then send a notification to keep them informed. And if they are satisfied with the case, then they can finally close the case and generate a disposition code, right? They can say whether they found any fraudulent activity or not. So you can literally use your imagination that how you want to configure this workflow, or you can go by your business requirement, and then you can send email, you can send a notification, a text message, whatever you like. So every action that you take on this workflow, we kind of keep a track of it. So every time you open the case, we are keeping an audit that who's looking at the case, who has been assigned to, what actions have been taken, and so on. And then we can also keep a track of your notification, right? Who gets notified on a periodic basis for this case? Because every time you're assigning the case, it gets notified to an investigator or a reviewer, and we keep a track of all those notifications. So this is the case management part. Now I would like to show you the data science, how the models are being created, right? So here we are looking at, we can create a model. So before you create the model, you will create the features, right? So let me go to the features here. Uh, and then you can either create the features from here, or and then once your features are in place, you can have all the models, right? So this is one of the model I'm going to show you, which is sitting in HopsWorks. So this is a model for fraud monitoring. These are all the features. This is the algorithm. So we are looking at the gradient boost tree as an algorithm. Out of the box, we have 40 algorithms in the accelerator. But if you want to use any other algorithm which is available as a Python library, you can use one of the Python APIs of the HopsWorks, which allows you to choose any algorithm you want. So the point here is like, you can build your features and store the features in HopsWorks. Once the features are available in HopsWorks, you can train a model. So first thing is to define the model and all the features. So these are all the features that are available in the model. You can also do imputation. If there are blank values in it, you can do encoding, you can do scaling and so on. Once the model is defined, then you can say, I would like to train this, because now you can have multiple versions of your features, right? You may have three different versions of the feature, because HopsWorks as a feature stores it gives you a time travel feature. Every time you're updating a feature, it's creating a new version. So when I'm training my model, I can say I want to train my model on a feature data set as of a particular date, or maybe the version number 2 or so on. If you know what version you want to train, you can use that, or you can use some the time-based ideas, right? So here I'm looking at, again, a Hobsbawm model, which I would like to train. I can select my feature store, like where my data is coming from. Then I can pick what's my label, what's my identifier within my data, and I can map all the features from HopsWorks to my feature model here. And then you can do a lot of settings while you're training the model. You can do hyperparameter tuning. You can save your results, like a training and the test results. You can save your output of the model in HopsWorks. So in this particular case, we are trying to save the model into the HopsWorks repository, and then we can train the model. So once you train the model, what we do is we use the HopsWorks ML engine. We train the model in Spark, and then we store the model as an artifact within the HopsWorks repository. So now I can take a look at the results. So we're going to look at the summary. So this is using gradient boost tree. These are all the parameters that were used for training the model. I can look at the feature importance. So in this particular case, I have a bunch of features, but looks like two of the features which are coming out of Neo4j are taking the most importance. So there is a community risk score, which uses community algorithms from the Neo4j graph database. And then you have the degree foster, like how many degrees I'm away from a fraudster. So we have used this feature. So we are using Neo4j to enrich our feature engineering process. And then we are storing those features into HopsWorks and then making a prediction using the ML, the machine learning algorithm. I can look at the performance of the models. I can show you the confusion matrix, the prediction classes, all the, the key metrics that you would like to see in a model. You can also look at the feature weights. So feature weights basically allows you to look at a particular prediction and see which features have influenced the most, because the features which are influenced the most is giving you an idea that why this prediction is made, right? And then you can pick any particular customer you like, and then you can look at all the feature weights on this. Okay. So once the feature is done, then I can look at the knowledge graph. So the last part I want to show you is the knowledge graph, where we have created a graph where we are using the Neo4j technology. So I have the knowledge graph here. So this is the graph that we have created. So the Infinix Accelerator allows you to define your graph in a no-code way. You can define your nodes, you can define your edges, the color scheme, the icons, etc. And you can also define some highlighting conditions. So here you can say, I want to use some condition. So if this particular account has a customer which is having a PEP flag, then I would like to highlight, or maybe if there is a fraudulent activity in the past, then I would like to show a red circle around it. So you can define your highlighting conditions, as I mentioned. So there's a lot of visual aspect to it. And once you define this graph, then you can store this graph in Neo4j. Okay. Once you do that, then your data gets moved into Neo4j. Now you can start analyzing this. So there are multiple applications of Neo4j. You can use it for the feature engineering process. You can use it for the investigation process and so on. So let's look at how you can analyze this graph, right? So I can look at, for example, I want to look at all the individuals who are sharing the phone numbers. So I can click on it and I can see that. So as you see here, these are the two phone numbers which are being shared by multiple people. This one is shared by Liz Simon and Bobby Smith. This is shared by three other, maybe it could be a combination of an institution like a company as well as individual. So, and you can also look at if there are any shared SSN numbers, because this is definitely a red flag. How can you have the same SSN number shared by two different people? So when we do entity resolution, we create these linkages. And once these linkages are created, you can start analyzing that graph. And now what you can do is you can, if you look from an ML perspective, I know that these two guys are sharing the same SSN number. So I can create a feature on these two individuals, and then these features can make its way into the feature store, which is the HopsWorks. And then now you can train an ML model, which will kind of look at these guys as more suspicious because they are the ones who were sharing the SSN number, right? So now you can understand that how we are extracting the features out of Neo4j, putting it into HopsWorks, and then using it as a part of the ML engine to do a better prediction. Um, I can also look at something which is like who's ultimately the beneficiary owner. This is more for structuring. So here you can see that there is a company called Acme Corp, which has these companies are holding, having some kind of holding into this company. And then this company has holding by these two guys. So you can use this graph technology to see, to do a lot of visual analytics, like network analytics, to see who's connected to whom. It can be used for feature generation purpose as well. It can also be used for visual investigation, like, network analysis. Um, there's one other feature. So now I'm going to show you one other experimental feature where we are bringing Gen AI. That is something in works. So HopsWorks as a platform allows you to run your LLM models out of the box. And Inferix as an accelerator will leverage these LLM models to make predictions out of it, where you can ask questions for more of on the unstructured data. So before I go and start showing you that particular new feature that is coming up, I would like to show you how these pipelines can then be automated, right? So there is one suspicious activity pipeline here. Uh, as you can see, what I'm doing is we are generating the features using the Inferix platform, and then we are writing those features into HopsWorks. Once the features are written into the HopsWorks, we can train the model, and then we can do some evaluation of the model. So basically, this will allow you to drag and drop and build a pipeline where you can, like, not only start from feature engineering, but you can actually create a pipeline to pull the data from your source system, do the massaging of the data, build your features, write it into HubSpot. All of these steps can be performed using one single platform, which is Inferix, right? And then obviously we use ML engine, which is HubSpot under the hood. So now we can also look at, there are two features I want to show you quickly. One is the lineage, where I can see how these features were constructed. So I can, let me go to the training here. And then I can open this lineage. Okay, let me quickly click on the lineage. Okay, so here you can see we have a lineage where, so let me go one level. So there are two ways you can look at the lineage. Either you can look at the lineage from an entity perspective or an attribute perspective. So this you can see is a very complex lineage idea here. So these are all the features which are a part of your ML model. Then these features we can see are coming out of some formula. So there is some calculation involved in this. So this was the formula. This formula is constructed using two different attributes. One is direction, which is a part of a particular table. And then you have another table which is contributing transaction type code. And then we can see that further down the line, these attributes are coming from other data set. These data sets are coming. So if you look at direction, it is derived from a string variable. So there is a string variable where you have defined the direction as incoming in this particular case. And then this value gets propagated all the way into the feature store through these calculations. So this is basically a data lineage. I really doubt if there are many tools out there which can show you this lineage. This is a very powerful feature where you are not only making predictions, but also you are explaining after a prediction is made that how this prediction was made, in the sense which features contributed to this prediction, and then how these features were constructed, right? What went as an ingredient to build that feature. So this is one powerful feature that is available out of the box as a part of the accelerator. You can go all the way till the source. So if you can see this, some of the feature values are coming from all the way from a file. There's a file coming into the system, which is transaction type, and that data is kind of moving into the system through multiple hops, getting constructed into a feature, and then the feature is used into a model. Okay, so this is the data lineage aspect of the feature engineering. Now I'm going to show you the last thing, which is the LLM part. This is an experimental thing that is happening. So I'll show you. Okay, so I'm getting into the same application. This is my dev environment where we are building this new feature. I can go to my knowledge graph. I can say I want to go to the Gen AI. I can choose my graph, and then I can say show all accounts. Let's see if this works. So the expectation here is that uh, what's really going to happen is, so depending upon what language you type, right? So this is going to generate a query that will basically a cipher query. So right now we are working on an idea where you can type any question you want in a natural language, which will translate into a query for you and then bring that query. So that way you don't have to really learn the cipher language because it's a bit complex language. Similarly, what you can also do is, like, in future, we are coming with a feature where you can type this text and you can also extract features from the feature store and build a model out of it. So this is a part of our roadmap. Now let me show you a quick snapshot of the result here. As I mentioned, this is an experimental feature which is happening. So I have some screenshot. So as you can see here I was saying that show me all the accounts for Marcia as a customer. This is the customer I'm looking at, and then it's going to result in terms of the network graph. So I'm looking at that this is my customer, and for this particular customer, what's my account? So this is for a particular customer. Now, similarly, if I want to see some other query, so this is a query where I'm saying show me all the account for a given customer, then I can get all the customers and every account associated to each of those customers. So this is more like looking at the complete population of the data. Okay, so we'll be releasing this feature soon, maybe by end of January in our next release. And then you should be able to go on the cloud, subscribe to the Inferix platform, and then start playing, on this platform, which uses Hopsworks and Neo4j as well. Okay. So that's on the Gen AI side. And then you can obviously, use the LLM model that is available on the HopsWorks. You can build other applications as well. But this is one of the features where we are leveraging the LLM model of HopsWorks within Inferix. At the end, you would like to build a dashboard as an outcome. So I can now go into the dashboard world. So using the Inferix accelerator, you can drag and drop and build various visualization. I'm just going to open one dashboard here, which is, let's say, I'm looking at a customer 360-degree. I can pick one customer. So this is a customer I'm looking at. So you can, get images, you can get the customer information, the address. So this is an AML dashboard for customer. You can look at all the account details. You can look at the alerts that are generated on the customer. Now you can also bring the outcome of your predictive models here. So this is basically the alerts which is generated by the predictive model. We had another use case where we were doing customer analytics, where we are doing the next best offer, or like, the recommendation engine. So we can also bring another pod here, which will show all the recommendations that are made for a given customer, right? So using this approach, you can build your visualization. Some of this visualization can come from an RDBMS database. Some of the data can come from a graph engine. Some can come from Hopsworks because it's a feature store. So you can really mix and match all the data across your systems and then create these dashboards. So this is something which is out of the box on the Inferix platform. Okay. I think that is it. I pretty much covered all the modules. We have like another 11 minutes, so maybe I'll take 2 minutes to show you one other thing, which is how do you create the features, right? The feature is basically some kind of mathematical expression. So let's say I was computing the number of the outgoing wire transfers. So you can provide a complex, whatever SQL expression you want to provide, you can provide here. So this could be as simple as dividing A by B, or you can do an addition or a subtraction, or maybe you want to do some kind of window function, which is like a roll up. You can define your business logic here. Once the logic is defined in the form of a SQL, then this becomes a feature. And then this feature can then be ingested into Hopsworks, and then it can be used for machine learning model, right? So this is how you will build the features using the Inferix platform. Okay. Yeah, so there are other modules as well. I'm not diving into each of these modules. You can look at our webinars, or we can have a follow-up. So Nate, I'll hand it back to you, and we can take any questions at this point.